A boy weighing 60 Newton stands in an elevator that is ready to move. Find the boy's apparent weight. Apparent weight is the same thing as saying mass. Apparent weight, another name for apparent weight is mass. And we know that weight is equals to mass times gravity. So if the boy is weighing 60 Newton, the mass we don't know, but we know that G is constant, and here they gave it to be 10. So to get the mass will simply be divide both sides by 10. So the apparent weight mass is equals to 60 by 10, 6 kg. That is for I. The boy's apparent weight is the mass, 6 kg. So that thing you normally call, let me go and measure my weight. That thing is apparent weight, which is mass. That's why you normally see it in kg. And they said the resultant force acting on him, II, as the elevator moves upward with acceleration of 3 meters per second. Take G equals to 10 meters per second. II. So first of all, when a body is moving upwards, normal reaction. I told you anybody you see has gravity acting on it downward, normal reaction upwards. So in this case, as it's going upward, weight, which is mg, will be in the negative direction, equals to ma. So which means that the total force of the system, because this thing now, the force acting downward is weight, the one acting upward is normal reaction. So the total force of the system is equals to ma. Are you seeing it? Which means that resultant force is equals to the mass of the ball is 6. Okay, we got it here. Is 6. Now they said that it's moving upwards with acceleration of 3 meters per second. So times 3. So total force of the system will be equals to 18 Newton. This is a way to go about it. But if we don't want to do it this way, we can simply say N minus W equals to MA. Then N minus mg, weight is equals to mg, ma. And this is set as N equals to ma plus mg. So that N is equals to ma is here, mass times acceleration, 6 times 3 plus 6 times 10, gravity 10. So this is going to be the same thing as saying 18 plus 60. N is equals to 78 Newton. So that is for N, the upward force. So upward force. But remember that this thing is weight. This is weight. And this is the force going upwards. Force upwards. And this one now. Sorry. Yes. This is the force going upwards as an acceleration. Why this one that we've gotten here is simply the upward, or you say this is just force. This one, sorry. This one is just force. This is just force. This is force. Why this one is upward force. So to get resultant force, we can simply say upward force minus weight force, which will give us upward force is 78, weight force is 60, equals to 18 Newton. So you can do it this way, or you just remember to do it this way. Whenever they ask you resultant force, what they asked you is not the force for a body to move up. But whenever a body is moving up, this is the force that you get using that our equation for an elevator. And when you are through with it, the resultant force, you now get it this way. Okay. I know you are understanding me. Keep it up. An object of mass, look at it on the inclined plane, rests on a plane. The coefficient of static friction, mass, let me write, mass equals to 3 kg. The coefficient of static friction and that of kinetic friction are given by mu s equals to 0.3 and k equals to 0.2. The plane is inclined at an angle to the horizontal. Find the maximum value for which the object remains at rest. Value of theta for which the object remains at rest on the plane. Okay. So the I part is to find theta value for which the object remains at rest on the plane. So let's try to see if we can solve this. Okay. So I know that a body on an inclined plane has weight on x-axis to be mg sine theta and weight on y-axis to be equals to mg cos theta, and the normal reaction minus w is equals to 0. That is on the vertical component, so that n is equals to, that is wy minus wy, so that n is equals to mg cos theta. Yes. Then we need to remember that when a body is at rest, f of s is equals to mu s n. So that means that this is the same thing as saying s mg cos theta. The same thing with f of k is equals to mu k, coefficient of kinetic friction, times normal reaction, which is equals to k. Okay. So if I know this, when a body is at rest, it will have, if it's at rest, it will have f of s, that is coefficient of static friction, minus force on x-axis is equals to 0. There will be no movement, ma, and a here will be 0. So it will be equals to 0. And f of x here is certain as in weight on x-axis minus f of s. So it will simply be coefficient of static friction is equals to weight on x-axis, which means that coefficient of static friction times mg cos theta is equals to mg sine theta. So this can cancel this, so that I now have coefficient of static friction is equals to divide both sides by the coefficient of this. I have sine theta over cos theta. That means that this will now be equals to tan theta, and they give us this to be 0.3 equals to tan theta, which means that theta will be equals to tan inverse of 0.3. There you have it, little man. Alright, so do tan inverse of 0.3. When you do the tan inverse of 0.3, whatever you get, that's your answer. So we did it, and this is what we have. So theta is equals to 17 degrees. Okay. So at rest, remember the question. They said find maximum value of theta for which the object remains at rest on the plane. So doing that, we have 17 degrees. That is, we got theta to be approximately 17 degrees. Theta is equals to, we got 16.69. So approximately 17 degrees. Okay. Now the next part says find acceleration of the object if it started sliding from rest down the plane at an angle theta max to the horizontal. So the I part is 17 degrees. So I part is what we want to do now. So a body on an inclined plane only has movement this side, and this movement this side is mg, at an angle, and the angle on this is not cos, yes shebi, and on the x-axis is sine, so mg sine theta. Go and check our inclined plane video. So we can now say force on x-axis is equals to mg sine theta, and we know that force on x-axis here is the same thing as saying m a yes, so we know that this is max is equals to mg sine theta. So this can take care of this. So acceleration on the x-axis will be the same thing as saying g, and here they say we should take g to be 10. Shebi? Yes, they say we should take g to be 10. Remember? Okay, but even if they did not say anything, we can use 9.8 or 10. So I want to use 10. So I say 10 sine theta. We've gotten theta to be 17 degrees. So do it, whatever you get is your answer. So 10 sine 17 gives you the acceleration to be 2.9237. So the acceleration is equals to 2.924 meter per second square. So please always remember that there is no force on an inclined plane. There is no movement, no acceleration on the y-axis. It can't move up, so it's on the x-axis. So for that reason, we say that force on x-axis is equals to mg. That is the weight at an angle, which is sine theta. We've done this. So when you do it, you cancel, you get the formula, which is ax equals to g sine theta. So it says sliding down. So if you observe very well, you see that what we used here, theta that we used here, is theta that is at rest, when this object is at rest, and that is what we got at 17 degrees. That's what we used. So when the acceleration now, when it starts sliding downwards, acceleration downwards now will simply be, there will be presence of wg, that is weight on x-axis. Then as it's going downwards this way, frictional force. So as it's going down this way, as it's coming down, like as it's sliding downwards, notice that the friction will be going in the opposite direction. Like, you know that anytime you want to come down friction wants you to go the opposite direction. So as it's acting down this way, friction will be going in opposite direction. The friction there will be kinetic friction. So it is all equals to, everything down here is all equals to the mass of the body times the acceleration of the body. And this is acceleration at x-axis. So what we've been able to get here, so remember that Wx is the same thing as saying mg sine theta minus Fk. Remember what we did here. So Fk is equals to coefficient of kinetic friction times mg cos theta is equals to max. So if you do the simplification, you now have that this is mg sine theta minus so acceleration on x-axis will be equals to remember that there's mg here, will be equals to mg sine theta minus at this point ax acceleration is going to be half g outside sine theta